Thank you for joining me again. Now, we are treating an exponential trigonometric equation. It's an equation, it's not linear. It's exponential because we have trig functions being the powers of those values that we are having in the equation. So now we are looking for theta. Find theta. Where theta, of course, it can be in the range such that 0 can be less or equals to theta, and theta can be less or equals to 360. But let's just find theta. How do we go? Looking at this question, we have this. Let's look for a trig identity that connects this and this together. Let's start from there. So if you recall that sine squared theta plus cos squared theta is equals to 1, right? Now for the IGCSE student and most special student, you can see similar question. It's an IGCSE question. So they ask this, what do? You know that your sine squared theta. I want to make everything here, the exponent to be of similar trigonometry. So what do? I can say this comes here, so we are having this with 1 minus cos squared theta. Right? So having that, let this represent sine squared theta. So we are going to be having 3 what? We have 3 sine raised to the power 1 minus cos squared theta, right? Then plus 3 raised to the power what? Cos squared theta. So what do we have next? Simplify these terms. The expression, therefore, that is equals to 4, right? So let's simplify this. We're going to be having what here? We're having 3 raised to the power 1 by indices now. The law of indices. This is a power, right? So this will carry raised to the power 1, then times 3 raised to the power minus a negative cos squared theta. Then plus, this one remain what it is, 3 raised to the power cos squared theta. That is equals to 4. Then let's continue. What can we do from here? We have this thing remains as what? It remains as 3 raised to the power what? 1. Then times a negative power means it will give us a reciprocal. So that means 1 upon 3 raised to the power cos squared theta. Then plus what? Plus 3 raised to the power cos squared theta. Everything is equals to 4. Can you see something here? There's something that is now common. We have 3 raised to the power cos squared theta. Here, we also have the same thing here. So let's go and represent. Let's represent. So we say let 3 raised to the power cos squared theta be equals to, let's use a, for example. It makes our work easier. So we have 3 times 1 upon a plus a is equals to 4. I think it's easier this way, right? So we now multiply it by this a to clear the fraction. So we're going to be having a times 3 times, we're going to be having this to be 3 plus a times this gives us a squared, and that is equals to 4 times a, 4a, right? So bring this, we have already a quadratic equation. A squared minus 4a plus 3 is equal to 0, right? So we can now solve this quadratically using any principle of solving quadratic equation, which can be what? Factorization approach, computing the square, general formula method, even the graphical method. But it's easier using it's easier factorizing here, right? So we have factorizing what I'm going to be having. And clear this. So if we clear this, we're going to be having what? We're going to be having a squared minus a minus 3a plus 3 is equal to 0. So see this? This and this give us this. This times this will give us this, right? We are correct. So now factorize by grouping. We are having what's common here, a open bracket a minus 1. What's common here, we have minus 3 open bracket a minus 1 Minus times this will give this time this will give this. So we are good, right? It's equal to 0, then we have a minus 3 or a minus 1 is equal to 0, which implies that what? A can be equal to 3 or your a can be equal to 1. Then we go back to where we say we should let this be equal to this. So we can get, we need the values of theta, right? So we can say, recall, we said 3 raised to power cos squared theta is equal to a. Now, when a, we have two values of a, 3 and 1. When a is 3, what do we have? We have 3 raised to power cos squared theta to be equal to 3. Now, this is same as 3 raised to power 1, right? So, to take the log of both sides, or you just consider them in indices. If you have this, the same base and two equation sides, what happens? The powers will be equal to each other. So we have cos squared theta to be equal to 1. Right? So what do we have? Take the square root of both sides. So cos theta can be equal to the square root of 1. So that means cos theta can be equal to plus or minus 1. Right? So you now consider when, so we can say theta can be equal to the cos inverse of 1, or theta can be equal to the cos inverse of minus 1. Do you see this? So when is cos inverse of, when we have theta to be equal to cos inverse of 1, what will be the cos inverse of 1? From here, theta can be equal to what? Cos inverse of 1, that should be 0. So which means cos theta can be 0. You check your cos 0. Cos 0 is 1, right? So we have cos 0 to be 1. We have that given already. Cos 0 is already 1. Then we can still have others. When can it be negative? When is the cos inverse? When we have theta to be equal to the cos inverse of 1. Shift your cos inverse. So we have that. That is 180, or theta can be equal to 180 degrees. This is when a is 3. What happens when a is 1? So write that out. And when a is 1, when a is equal to 1, what happens? So you say again, 3 raised to power cos squared theta is equal to 1. So what happens here? This is raised to power 1, doesn't change anything. So 1 is the same thing as 3 raised to power 0. So if I let me obtain this, we have 1, and that means that 3 cos squared theta is equal to 3 raised to power 0. Because 3 raised to power 0 is the same thing as 1. So we are good to go. This one, that means cos squared theta is equal to 0, right? So cos theta should be equal to 0. The square root of 0 is still 0. So when is do we have? That means theta should be equal to cos inverse of 0. And that is that what? That would be 90 degrees. Cos 90 should be 0. So we have that. Perfect. So we have that as that, and we are good to go. Thank you very much for staying with me. See you some other time. Bye.